All right. Hi everybody.
Hi,
So
everybody.
we're here for the Assignment 2 intro video, which hopefully you were aware is Pac-Man Capture the Flag.
And we've already seen the assignment in the assignment specification. Here we will talk more about the details of this challenge, and we will discuss what you can do in your assignment and how the current staff implementation looks like and what drawbacks it have. So as you can see here that we have a picture showing in the middle, and it have two teams of agents. And for the team on each side, they have to compete with the other side and try to eat as much of the food as possible from the opposite side. All right. So
And so one thing you'll note here, right, is that when you are on your own, your home territory, you are the ghosts, and so you are able to eat the invading Pac-Man. And then the inverse being, of course, that when you're in the enemy territory, you become Pac-Man, and you yourself are susceptible to being eaten.
yeah, and you win the game if you capture like as many dots as possible from the other side, and so don't get caught when you are like trying to eat food, and because you need to bring those food to home, and you get the score for real.
Yeah, so effectively it's like when you eat food and you're still in the opposing team's territory, you have it in what's called like a backpack. And so yeah, if you're killed on the way back to return to safety, then all the dots will return to their locations. So yeah, you need to actually get into home territory in order to score the points. Okay, so for the game rules, effectively here of course we have, there'll be a series of grid mazes that you fight on. Time is discretized into unit time steps where the agents are taking a single action at each time step.
And so also you can see that these agents, they take actions one by one, turn by turn. And also like the status and the position of the offset team is partially observable, which means like if the other team is close enough to you, you know their position. But if they are beyond 5 grid size to you and you don't know their exact location, and in the environment they will provide you a noisy distance, but this is not an accurate one. So you can see more details in the description from the specification.
Yeah. And you kind of have a measure. You are aware when it's a noisy distance versus not. Okay, so at each time step, effectively, you're given a game state, which represents all the information you kind of need to know and can use to make decisions.
Yeah, for example, you know your location, and you know is yourself a Pac-Man or yourself a ghost, and you also know if you are scared if the other side eat a capsule. So remember, capsule is important because when the other side eats the capsule, and your agent will be eaten, even you are at your own land. Also, like you know the information about the remaining food and the remaining power capsules, and try to use them and to maximize the ability of your agent. And for the decisions from your agent, it's also very simple. It's just for each of the agent, you need to decide at each time stamp, should it go up, down, left, or right, or just stop at the current location. So what is your task? Your task is just to develop an AI controller for your agents so that they can capture as many foods as possible from the offset team of the map, right? And this is your main target. But also remember, when you capture some food, you also need to bring them safely to your home, and so that they turn into a score. And also remember, you can use the power capsules on the map, right? And the power capsules are white points on the map, which are unfortunately not shown in this picture, but you can see it in the videos later. If you eat a power capsule, you no longer need to be afraid of your enemy at their line, all right? So take advantage of these power capsules and weaken your opposing team, right?
Yeah. And to note, like when someone eats, when a Pac-Man eats a power capsule in the opposing territory, both of the enemies are feared, I believe is the term.
Yeah, and remember, although you are planning your agents individually, but you still want them to work together as a team. So think about how you should do that.
Okay, so yeah, we've been talking about basically like how the game works, the rules of the environment, the game state itself, But how do we start? So we're going to walk through each of these points individually, but this is a high-level figure that's really useful for kind of like understanding the cyclic process that's going to be going on here. So the first thing we're going to be having a look at is choosing a high-level goal.
So what is a high-level goal here? And as you can see, we have an example on the bottom. So in the game, you want to make some big decisions. For example, do you want to gain scores aggressively because currently you are not in a winning status? You are not like far ahead of your enemy team. And all on the other side, and you can choose defend your food only if you are far ahead from the enemy team and you have lots of scores like already gained. And so a high level goal is just choosing between these two, or you have more options like you designed by yourself. And yeah, and then if you have a high level goal here, what's next? So you might want to know how I can achieve this high level goal. So then we need to move the process of like generating a high level plan.
So effectively, right, like we've already had this idea that you observed the game state and then you were able to reason over that, however you choose, in order to determine which high-level goal we should have. And then we need to develop a high-level plan in order to achieve this. So the high-level plan itself consists of simply a sequence of high-level actions. Right, so in the case that we're talking about, you're in the mode that you want to go score points aggressively. You then you have through PDDL effectively, you will be creating this list of high-level actions. So in order to execute this plan, you might choose to go to the opposing side, then you can eat the food, and then when you've eaten enough food in some form, then you will need to go back home, which is effectively necessary to score it. Yes, but however, we talk about these high-level strategies, but this kind of tells us actions we should be trying to do, but it doesn't describe the actual necessary steps in order to complete them. And so in order to do that, we move to
the low-level planning part, right? So as an example out here, so if you say, okay, my first high-level action is just to go to opposite side, and what should you do to achieve this? So now we need to generate a low-level plan. So for example, we can use heuristic search, or we can use reinforcement learning, and so that the planner can return us a list of actions that we can do. So as an example here, if you have that high-level action, and the low-level should return you a plan like, okay, going south first, then east, and then north, something like this. So. And after you got a plan, and you will execute the plan, and at each timestamp, and you will return one of these low-level action to your environment.
Yeah. So effectively, right, like the high-level plan, kind of as we talked about in class with the whole PDDL, you have these preconditions that kind of need to be met in order to say, hey, this is a valid action that we can take, and then we look at the effects of that action. And so, yes, the low-level strategy you're choosing, the sequence of moves, is developed separately at the low level, and it's meant to execute the action such that the effect is true at the end of your movements.
Yeah.
And so here, effectively, after we develop the level plan, we execute the move, right? And as we've talked about, the game state has individual time steps. So by execute the move, we effectively say, we have a list of moves that we should be taking. We take the first, or the current action.
As shown in the example right here, so this low-level action is a real thing that the environment wants. So if you give a source to the environment, the source will execute your plan and move your agent to next location. So we talk a lot about generating like high-level plan with PDDL. And so we also provide you an example PDDL implementation in the code base. And at here, so we have a list of predicates, but some of the predicates are used in the current action models, but some of them are not. So you can try to take advantage of these listed predicates and try to use them in the existing actions or use them in some new actions that you modeled on your own. So, and to give you some hints on how you should do to improve your agent, and we can look at the behavior of the staff implementation to see what drawbacks they have.
Yeah, and so we've tried to provide you guys with as much useful information as possible so that you can use these predicates to reason in however you want. But as we'll discuss, you will be able to add to those if you come up with new ones yourself. Anyway, so here we have a very quick demonstration of the red team here on the left is the staff implementation, and effectively it's not great.
And the blue team is another baseline from the Berkeley who developed the game. And you can see now we can see the first drawbacks. These two agents, they are not that clever. They're always chasing the same food and together. And also, I think previously you see that these two agents, they eat the power capsule, right? And the enemy is scared. But none of them are aware that they can take advantage of that and they just quickly run back to home. In fact, they can eat the enemy if they have the power capsule.
Yeah. So you could imagine, for example, that based on the game state here, that we've eaten a capsule and that the enemies are feared, you could think that you should switch to a different high-level goal. Well, now we don't need to eat food. Why don't we try to eat the enemy ghosts, or Pac-Man now, I guess. And yeah, so at the beginning as well, we were just mentioning, like, because the two agents don't have good reasoning over where the other one is, or this idea of cooperation, they effectively just kind of end up doing the same thing. So they're chasing the same food.
Yeah, we just see another thing that is, you can say, because the red team is currently winning, and so they choose a high-level goal to defend only, but they are not aware of where their enemies are, right? They are out of the observation range. And in fact, they should take advantage of, like, okay, which food is eaten just on the map, so that they know, like, generally that where the enemy currently is around. And also the environment provide you noisy distance. They could use and take this advantage.
Yeah.
And also in this defend mode, you can see these agents are just wandering on the land, and they are not, in fact, trying to define some important locations, right?
Going back to spawn is probably not ideal behavior. Anyway, so effectively we're just showing you this because we wanted to demonstrate what the current issues are, but kind of like just to get you thinking about how you could improve your own. And this is a very default implementation.
Now let's look at another example here, so which we use staff implementation versus staff implementation. So, we see this, right? And we have a terrible infinite loop between these two teams because they all both want to go to the other team's side from the locations in the middle of the map.
Mexican standoff.
Yeah, but none of them like trying to do a detour, and they're just watching each other and waiting for the other side to, like, maybe go to my side and I can eat you, this kind of thing. And so, as we can see, they behave really bad.
Yeah, there is no, like, high-level action or low-level plan that was able to circumvent the idea that, you know, in this case, you'd hopefully want to switch goals or something of the like, or at least create a new plan when you notice that something isn't working.
So what can you do? And basically, we have a summary at here, so you can improve the high-level planning. For example, should you like have more goals, the high-level goals, and so you can handle more complex scenario? And should you like try to take advantage of those predicates that currently listed in the example PDDL but not used? And because our code already collected the states for those PDDL predicates, if you don't use them, then you wasted it. It's a pity. So, and also you should think about if there are any new predicates that you can add into the model and try implement the code to collect the state of those predicates. And also some new actions, and also think like, okay, how the current high-level plan of one agent complements the plan for its team. So you try to have cooperation with the other agent.
Yeah. Also note, by the way, you're given like agent IDs, so you can reason over like who's what and who's where and things like this.
And also we can implement the low-level planning better. So, and currently in the default implementation, there are several high-level actions share the same low-level strategy, so which is not that clever. And you should think that for each high-level actions, and you want to design like the specific low-level planning strategy for it, because some of the high-level action, maybe you want to avoid any kind of touch with anime agent, but for some of the low-level planning strategy, you want the agent to stick close to the anime agent and so on. So many things you can consider in the low-level planning.
Yeah. And so effectively, though, we have these two main methods that we probably expect these low-level plans to be created with, namely the first being heuristic search. So effectively just the first half of the unit here, you're allowed to search through the possible game states to develop a plan that seems feasible and achieves what you want to achieve. But then alternatively, you can also use Q learning, which is reinforcement learning, namely specifically approximate Q learning. And so here you will have to try to select, you're trying to train your agent to learn what's good and then to apply weights to all the possible things you can do, such that the actions that resulted in better outcomes are learned and to have a higher percentage chance of being taken.
So remember to get help when you fall into difficulties or you have any situation that you think you need some help. So you can check the assignment specification, read those documents carefully, and also the code description document, and that one tells a lot about the details of our staff implementation. And also find us on ad and find us on tutorials and consultations, and we will get back to you as fast as possible and try to help you accomplish the assignment.
Cool. Okay.
All right. Good luck with your assignment.
Yeah.
Okay.
And see you guys around and
See
each other
ya.
soon.
Bye.